Everything fails all the time. And in order to build resilient architecture, we need to embrace the possibility of failures and then build our systems to recover from these failures. When it comes to designing architecture for a highly available, durable, scalable, and a resilient database system, I would like to believe that everything does fail all the time. And my job as an architect is that when something like that happens, how to get things back up and running with minimal data loss and as quickly as possible. Welcome to AWS Online Tech Talk. My name is Anuja Malik. I'm a database specialist solutions architect with AWS. And I'm very happy to talk about global databases today and share all about the use cases, advantages, and the features of global databases. So let's get to it. So here is the agenda for this session. We will have a quick refresher. Um, we will have a quick refresher on Amazon Aurora for those of you who are new to Aurora. From my experience talking to my customers, out of the many features of Amazon Aurora, global databases is quite becoming the one that is attracting a lot of customers to adopt Aurora. And we'll see that in today's session why it is so critical. Then we will cover the fundamentals of global database and its key features. We will also cover the features of global databases such as managed RPO and managed planned failover, which are fairly newly released. We will end with a demo where you will get to see global databases in action. All right, so couple of things about Amazon Aurora that makes it different from the rest and that qualifies it as a cloud native database. Amazon Aurora is a high throughput system. And what this means is that using the scale out distributed architecture, we have separated the compute and the storage layer of the database engine. Now, the compute layer still does the query processing, the transactions, and the caching. But the storage system is really what is specially designed for the Aurora system. The storage volumes of your Aurora database is striped across the storage nodes, which are then distributed over three availability zones. So, Aurora maintains six copies of your data, two of each in the three availability zone. And that protects you not only against the availability zone failures, but it also gives you the high durability for your data out of the box by design. And many of you have probably heard about the quorum that we utilize for Aurora. Uh, this basically says that we need 4 commits to be able to do a write commit on primary, and we need 3 acknowledgements to do a read commit. Another thing that is different and unique about Aurora is that Aurora backups happen continuously. So there is no backup window, there is no performance penalty during the backup process because it's happening continuously. And this is something that many of our customers worry about with their database engines. Backup management is a whole is a broad topic in itself, right? The storage nodes in Aurora continuously write snapshots of these 10 gigabytes of storage into S3 along with the logs. So, in the event, if you need to restore from the backup process, the hundreds of storage nodes in the storage layer can simultaneously access S3 at the same time and apply the logs at the same time. So, essentially, this allows you the fastest restore time. We talked about the data and the storage layer failures. But what if there is a failure at the database engine layer itself? And of course, that could be a point of failure for your application too. So with Amazon Aurora, you can have up to 15 copies of read replicas across different availability zones within a single region. And these read replicas can be promoted to primary whenever your writer or your primary instance goes down. As you can probably guess, that the Aurora replicas also work very well for read scaling because these can be fully dedicated to the read-only operations on your cluster volume. However, what makes Aurora unique is that the replicas access the same underlying storage as the primary. There is no separate storage for the replicas. So, this type of architecture gives you a database service that is highly scalable with minimal latency because all the primaries and replicas all point to the same storage. There is no time wasted in replicating the data. So let's switch gears a little bit. We talked about the high availability and the fault tolerance of Aurora database within a single region. But how do you achieve all of that across the region, across multiple regions for that matter? So that's where global databases come into picture. Even before global databases, customers could replicate data to a remote region. However, they would have to go down the path of logical replication. That is, either by using the bin log in MySQL and PG logical in Aurora Postgres. And in today's session, we will compare these two replications and see where global databases have the edge. So, Amazon Aurora Global Database is a feature designed specifically for globally distributed applications, allowing a single Amazon Aurora database to span multiple AWS regions. So, with global databases, we are really trying to meet two major requirements. The primary one is disaster recovery to help our customers protect against regional outages with minimal data loss and, of course, with minimal failover time. The both of them go hand in hand. So let's say if they do have an outage in a region, an outage doesn't necessarily mean that the entire AWS region is down. There could be other things. Realistically speaking, an outage could be a network issue in your VPC. It could be a performance issue in your primary region. It could be that you implemented a change in your infrastructure layer in your primary region and that has caused a bug. So, for whatever reasons, you need to fail over to a copy of another region, and you don't want to lose data, and you want it to happen quickly. So, that's the primary design goal for global databases. It's also designed to help with geo distributed reads, to help our customers process read traffic which is closer to their users. By maintaining read only copies of your database in a different regions, you are lowering the latency of read only workload for your remote users. All right. Um, so, when you have a natural disaster, let's take a look at the fast cross region disaster recovery use case. When you have a natural disaster or some regional level availability issues, as I pointed to few in a few minutes back, global database distributes your data and replicates your data across multiple regions so that you can have remote readers that can be promoted quickly for faster disaster recovery. In this example, you can see that we have a primary instance, which is a writer and reader in the US East region. And using global database, we are replicating to EU West. So in this case, if US East goes down, we can switch to EU West and continue running our operations from EU West. One thing I would like to call out here is that, and it happens sometimes, is that when we talk about disaster recovery, we need to plan disaster recovery for the entire stack. Very often, people over index disaster recovery on databases. But failing over database to another node is not going to be enough when the actual disaster strikes. You need to ensure that all the components of your application are also configured to operate from this remote region. What's also important to note here is that when you create a read replica for Aurora within a single region, it is all synchronous replication. The primary node waits for at least 4 storage nodes to act before it moves forward. So it's completely synchronous and there is no risk of data loss. Whereas global databases implement a different replication technology, and we will talk briefly about that in a minute. However, between the regions, we have larger latencies, and therefore, it is not possible to have synchronous replication across the region. So, what I'm trying to say here is that read replicas, in region read replicas, are a fit for high availability. However, global databases are really meant for disaster recovery when you are prepared to incur some data loss. Generally, we are not that far behind. And again, we will take a look at the latencies in a minute. But bottom line is that if there is a disaster, you have to make a choice that do I want to bring up this region as a primary and continue running my workload, knowing that there might be some data loss missing. So the RPO, recovery point objective, is not zero in this case. All right, the second use case, you can also use these replicas as read-only database for your remote users who will have lower latency by reading from a source which is closer to their geolocation. So in this case, again, we have the primary in the US East, but we also have readers in the US West, in EU West, and in AP Southeast. And the benefit here is that A, if I want to improve the performance of read only workloads for my remote users, and B, if I want to distribute the workload across multiple readers and separate my reads and writes so that my writer has more bandwidth and more resources and therefore better performance for my writer node. So this is more of a performance use case versus the disaster recovery use case, which is the first one. And as I said before, uh, all of it was possible even before global databases by using the logical replication. However, the more replicas you would add to your primary database, the more resources the replication process will need because it is logical replication. And that might impact the performance of your primary database. Global database implement physical replication technology, and therefore it doesn't impact the performance of primary. And as a result, with global databases, you can achieve lower replication latency even with high number of queries or high number of transactions per second on your primary database. So let's say we have a primary in the Ohio region and the application is running against the primary. Using global databases, we have replicas in Oregon, as well as in the Northern Virginia and Ireland region as well. So using global databases, you can replicate your database to up to 5 secondary regions. And generally, you will have less than 1 second of cross-region lag, although it will vary with your workload and it also depends on the region and the distances. But we have seen a lag of less than 1 second. So the RPO that I was referring to previously, the recovery point objective, the data loss, is going to be of 1 second. So that's RPO. What about RTO? The recovery time objective. When the disaster happens, making any of the secondary region as your new primary, that generally takes less than a minute. So RTO is approximately a minute. And if you compare it to the RTO for current implementations of your disaster recovery, for example, trying to restore from backups, which is the most common one, that will take much more time. And our customers are really pleased when they know that with 1 minute of RTO for their databases across the region with global databases with no operational overhead. What about the performance? So global database supports very high throughput, which is generally a bottleneck and a cause of pain and latency when you think of any replication technology for any database engine. With global databases, it supports up to 150,000 writes per second and very negligible performance impact. And, uh, and we will see in the next few slides how global databases make it happen. All right. So, as I was saying, using global databases, you can replicate your database to up to 5 secondary regions. And then within each region, you can have up to 15 replicas. So, 5 secondary regions and one primary, that makes it a total of 6 regions. And each 6 region can have up to 15 read replicas. So, in total, global database supports 15 multiplied by 6, 90 readers spread across 6 regions. So you can have a huge read only farm for your application across the globe. One thing I would like to point out here is that only the primary region can have a writer instance. All of the secondary regions will only have the read uh, nodes. All right, so how does it really all work? We have already talked about how in Aurora the writers are sending log records to a storage engine. And this storage engine has its own resources and it operates independently from the database engine. It is decoupled with the database engine, right? So an Aurora cluster in a single region can have up to 15 read replicas, and those read replicas also consume the same log records. They consume those log records to keep their local buffer caches consistent and close to the actual writer. And therefore, as a result, we see that in region replica lag is typically in milliseconds. It is 10, 20, or 30 milliseconds. So that's the normal process. That's how the read replicas work. Now, the way global databases work is that in the storage layer, we have an additional component for outbound replication. So basically, the primary of the source region will have an outbound replication. And in the secondary or the target region, there is a corresponding inbound replication component. And these are really the sets. These set of agents are really microservices continuously communicating, where the outbound replication receives the same log records that all the readers inside the primary region are receiving, and it sends those log records across to the inbound replication agent inside the secondary region. Then, once the secondary region on the secondary site, the replication agent just acts as a primary, so it sends the log records to all of the storage nodes. And it sends it to the read replicas so that they can update any buffer pool pages just as the read replicas in your primary region. You would also notice Amazon S3 in the slide. So now you can have separate backups on your secondary regions, including the point in time recovery up to 35 days, and you can do snapshots. So yeah, you can also have cross region backups as part of global databases. With that information, now that you know a very high level overview of how what do we mean by physical replication that global databases implement, let's talk about performance one more time. Um, like I mentioned before, we can support up to 150,000 writes per second. And here we see comparison between logical cross-region replication, which you see on the left side, versus the physical replication that the global database is based on the right side. So you can see that on the logical replication, the x-axis is the time where we are measuring the latency, and y-axis is the queries per second, QPS. And uh, you can see that as we increase the queries per second, the lag on the secondary y-axis keeps going up. And when we got up to closer to, let's say, 250,000 queries per second, there was approximately 10 minutes worth of replica lag. That means 10 minutes worth of data loss in case of a disaster. And that also means that your reporting workload on your remote regions will have stale data by 10 minutes. So, can you imagine that with 250,000 queries per second, how much data you will lose in a time frame of 10 minutes? And for some of the heavily used applications, such as financial applications or e commerce applications, 10 minutes of data loss could cause a havoc and it's just not acceptable. So, if we go on the right side and look at the global database, you can see that we can take our queries per second to about 200,000 per writes per second. However, the replica lag always stay well below 1 second here. So again, going back to the fundamentals, inherently, the way Aurora storage is designed, it allows us to provide a high throughput and a high performance database without sacrificing the availability and durability. And what we are trying to do with global databases is the key to the same goal while increasing the availability and resiliency beyond the single region into a global infrastructure. So, to sum up the key features of global databases, it is a physical storage level replication that can be used for faster disaster recovery in secondary regions. You can also use it for cross region migrations and low latency read workloads. It is compatible with MySQL 5.6 and 5.7 and with PostgreSQL 10.14, 11.9, and 12.4. So let's take a quick look at how global database helps customers with an unplanned outage. So as I mentioned earlier, it is very important to design disaster recovery with every component of your application stack. What customers typically do is that they operate a pilot light mode in which they maintain a minimum set of sources in a secondary region, and that's ready to come to life in the event of seeding a disaster recovery. And the other factor is that the data locality in which the customer might want to maintain a copy of the database in the secondary region that's close to some of the end users for customers to provide lower latency. So we have a replica of database in the secondary region, and the application stack also exists in both the regions. Now, in case of a disaster, the reader in the secondary region will be promoted to be the writer. And then at the application level, something must be done to promote the application components to start taking the writes and to start sending those writes to the newly promoted writer. And once that is done, clients start connecting to the application through some DNS redirection pointing to the new stack that's running in the new region. Let's talk about managed RPO, one of the newest features of global databases. It's designed to let you control how far you're willing to let your secondary lag from your primary database. So let me show you with an example. In this example, you can see that I have my primary in Ohio region and my two secondaries are in Northern Virginia and Ireland. My application is writing to my primary database in Ohio. And let's say that I want to set the global database RPO parameter to 20 seconds. What does that mean? That means that global database is going to ensure that at least one of my secondary region is within the range of this defined RPO, which is 20 second. What happens if it is not? Let's find out. So the first scenario is that both the secondary regions have a lag of zero point 0.4 second. So it's business as usual, no changes. Now, due to some event, the lag in Northern Virginia goes up to 22 seconds. However, Ireland is still in the range with a lag of only 5 seconds. So primary thinks it is still okay to carry on business as usual because I have at least one good candidate across region, a secondary region, to fall back on in case of a disaster. So let's take it up a notch. Uh, and now the lag in Ireland 2 goes up to 21 seconds. And that's when primary thinks that this is a problem and I cannot operate anymore. So it controls the situation by blocking transactions from committing on the primary until at least one of the secondary database catches up and gets under the target RPO of 20 seconds. So the read-only workloads reports, those will continue, but any attempt to make changes will certainly be paused, and the managed RPO will allow transactions to start processing again on the primary node when any of the secondary is within the range of your defined RPO. So the trade-off is that you're giving up the availability of your database to maintain the cross-region synchronization. And there are workloads out there, there are customers who follow stringent regulations to stay within the compliance of 20 seconds RPO or whatever is their defined RPO across the region. Again, these are mostly financial workloads who have auditors who and these organizations need to prove to their auditors that these are the measures that they take to keep their data in sync within the agreed upon latency. Also, there are workloads that cannot afford to have stale data of more than few seconds or minutes across the globe. They would rather take down their service, disallowing their users from making any further changes rather than having stale data or risk of losing data of more than few seconds. And again, these are mostly financial customers, stock markets, tax applications who want a guarantee that they will minimize data loss in the event of a regional failover. Next, I want to talk about another enhancement of global databases, which is managed planned failover. When global databases were launched, you didn't have an option to move the primary region. So the primary was always the one that you started with. And what did it mean in the case of a disaster? Well, in case of a disaster, you would go to the secondary region, you disconnect it from the global database, and now it's your primary, regular primary, right? However, if you wanted to do, for example, a disaster recovery drill or for performance circumstances, you would like to move your primary to the secondary region. So earlier you had to basically disconnect global database, make a secondary as your new primary, make sure your application writes to the new primary, and then configure global database again. And then it will replicate all of the data uh, again. And this was a bit of a pain, obviously. And that's the pain point that global database managed planned failover addresses. It allows you to say that now I want to move my primary from region A to region B. And Aurora takes care of all the heavy lifting, right? So once again, let me show you with an example. I have my setup again. I have my primary in Ohio, and my secondary regions are Northern Virginia and Ireland again. And the application is running against Ohio in this case. And now, because of some reason, probably the most common thing is that you want to test out your disaster recovery solution, which is again a compliance exercise for a lot of applications and organizations, right? So, with global databases, you are simply moving your application, um, let's say, over to Northern Virginia. So, in this case, to verify that your DR plan works and is fast enough for your business. So, um, we click the promote Northern Virginia to be the new primary region. Then Ohio stops for writes. We make sure that we drain Ohio so that we never lose data. And this is all managed for you. And all of this happens in the background without you having to write your own logic or your own scripts or solution. And then the secondary regions both catch up to make sure that they got all of the rights that happened in the Ohio, because we don't want to lose all that data. And then now Northern Virginia now becomes the new primary. So now it is the primary and it can accept the right workload. What you as a customer is still responsible for is to point your application to the Northern Virginia endpoint, and you're good to go. So everything here is managed for you outside of your application, and that is managed planned failover. All right, so let me present a demo of global databases on how it works and show you a couple of features in action. All right, now let's take a look at global databases in action. So right now I'm on my AWS Management Console, and let me go to the RDS database console. Now we want to add another region to it. We want to make it a global database. So I'm going to choose that particular database cluster, go to Actions, and say Add AWS region. Now, once when I choose to add a region, obviously it is going to ask me that what name do I want to specify, right? So I'm going to say that this is going to be my database one, um, and I'm going to place it in, let's say, EU. You can follow any nomenclature, but the important thing here is that which secondary region do I want to choose. So I'm going to choose EU London, EU West. And again, with global databases, I have the flexibility to right size my global instance, my secondary instance. All right, so again, with global databases, I can either choose to have a replica that is multiple reader roads, or I can say that, yeah, I don't need a replica for this. So for this demo, I'm not going to choose creating a replica in the secondary region, right? And these settings, I'm going to choose my default VPC. You have to choose the VPC which is present in your environment, and the subnet group. Yes, uh, I as a best practice, I choose no for public access. And for the security groups, my default security group has all the necessary settings that are needed to connect to my database. And I say add region. For the demo purpose, I already have a global database which is across two regions. One is the US East 2, and another region that is secondary is in EU West 1. In my primary region, there is a writer and a reader node, and in my secondary region, there are just two readers. So in this case, I chose to have a replica even in the secondary regions, right? So let me connect to these two um, databases, right? So how do I, let's see, this is my primary and this is my writer instance. So I'm going to go to my writer instance, and this is the endpoint of my writer instance. So I have, all right, so now I'm connected to my primary. Let's see, this is AWS Summit PG Instance 1 US East 2B. Yeah, I haven't chosen a great name, but if you look at the string connection string, AWS Summit PG Instance 1 US East 2B. This is going to be my primary, right? Um, I have a database named AWS Demo. I'm going to connect to that database. At the same time, I'm going to connect to my secondary instance, and by secondary I mean the secondary region, right? So when I go to any of the reader, let's go to this reader, it is going to open the window in a new tab because I'm going to a different region here, right? So this is now, as you can see on my console, I'm in the Ireland region. This is the endpoint for my secondary. As you can see that this is Summit PG Global AP Instance 1. So this is my primary and this is my secondary. And let me connect to my AWS demo database here. All right. I have I created a huge table. Let's compare the results. As you can see that it has 137 million rows in this particular table. And I will wait to, this is my primary instance. I will wait to get the results from my secondary instance as well. So as you can see that on both the sides, we have the exact same data, right? So let me say insert into, I have a table So imagine that, not imagine, but I am going to insert 137 million rows into another table, which is global big table, right? Let's see how many rows does this table have right now. I'm running this query on my secondary instance. So there are 0 rows right now. So let me run this query and let's see what's happening on the primary side. All right, let's take a look at the general CloudWatch metrics. All right, so as you can see that while this table is running, I'm inserting 137 million rows into another table. Of course, my write IOPS and my write throughput is going up. Let's do our global database and let's go on the secondary one, right? And you can see that there is a spike, it's a lag, but it is still under 1000 milliseconds. So I'm going to let this query finish. All right, so now the query finished, the insert statement finished on my primary. As you can see that when I do a count star from global big table, I get 137 million rows. And even on my secondary side, on my secondary reader, when I do a count star, I get 137 million rows. So that means all of my data has been replicated to the secondary. Let's take a look at the replication lag, right? So right now I'm on secondary instance and I'm looking at Aurora global DB replication lag. And this is the spike that we got at the time when our query was running. So our query ran approximately for it started at 43 and 53. So 52. Our query approximately ran for 9 minutes, and for 9 minutes the average latency on this particular secondary instance remained below 1000 milliseconds, right? Let's take a look at what was the maximum latency that we got to, right? So again, this is the time when our query was running. So the maximum lag that went was about 3500 milliseconds, and then it was able to catch up, right? So the average stayed well below the 1000. Um, so this is one way of looking at lags by looking at your CloudWatch metrics. And there is another way. You can also get the lag directly by running the query. All right. So running this query will tell me which is the AWS region, which is all these things, right? The main thing I'm looking for is the RPO lag in millisecond. And there is another query. While this gives me at the cluster level, I can also get this information at the instance level, right? So as you can, if I go back to my topology here, you will see that I have 4 endpoints for this particular cluster: one writer, reader, and then 2 readers in the secondary. So I can get the lag over here for each of the instance. Why this is so important is because you should absolutely use this information when you have to make a failover decision. So if I have to failover in case of a disaster, I'll run this query, find out that which instance or which region has the minimal lag, and then choose that particular region as my primary. All right, let's quickly take a look at how can we set up RPO, the managed RPO with global databases, right? So as I said, that you can define that I want my managed RPO to be, let's say, 20 seconds. The minimum value you can set is 20 seconds. The most common value our customers choose is 60 seconds. So how do we do that, right? So it's a setting that needs to be defined via the parameter groups. So I'm going to create a parameter group. This is going to be for my Postgres 11, and this is going to be a cluster parameter group. And I'm going to say that this is managed RPO for production servers. Create. All right, now that we have created the parameter group, I go there, and once again, I see that there is a parameter called global DB RPO. I choose to edit the parameter, and I can say that at any point in time, at least one regions should be have should not go should have minimum 60 seconds of latency, right? So I can do save changes, and before making the change, let's say I quickly want to see what is my current managed RPO. So I can run this command, show RDS DB RPO, and if it is -1, that means it's the default value. I can also run this command on my secondary as well, right? Um, so let me go ahead and apply this parameter group to my primary instance, the primary cluster. All right, so here it is, managed, and I go to continue, and I say apply immediately. Okay, let's try running the same query again. And there it is. Now we see the global DB RPO is of 60 seconds, right? Okay, one last thing I wanted to show you is, of course, the managed failover, or what are the steps in case of even unplanned failover, in case of an unplanned outage, right? So for managed R planover, it is as simple as that on my primary region, or even from the secondary for that matter, um, I choose my global instance, I go to actions, and I just simply say fail over global database. When you go to that page, it is going to ask you where do you want to make it primary. And in my case, I just have one secondary region, so it's an easy choice for me. But uh, for if you have several regions, and if you have to make that choice, then as I said, run the query to find out which region has the minimal lag, and then choose that region to failover, because that region will give you the minimal uh, RPO and RTO. All right. And that is managed failover. Right. After a few minutes, the failover is complete. And now, as you can see, that my EU West region is now the primary, and this has become my writer instance, whereas the US region is now shows as secondary. And all of this I was able to do by simply going to actions and saying fail global databases. If I, uh, so if you remember, this used to be my primary before, right? Right now I'm connected to AWS Summit PG instance 1 and the US East 2, right? So I ran the insert command on this particular instance. So let me take that insert command one more time, Let's try to run it again this time. And I get an error that you cannot insert this and cannot execute this because this is in a read-only transactions. Whereas I can take this command and I can run it on my new primary, which is in the EUS. So that's managed plan failover of how you can simply at the click of a button uh, choose to make any of your secondary region as your primary. If I were to, in case of an unplanned outage, if I were to promote my secondary region as my primary, I need to choose that and just say remove from global database, and it will tell me remove and promote. And that's how my this particular cluster will be detached from the global database and it will become the new primary. So hopefully that gives you an idea of how global databases work, what are the important settings, how to use the parameter groups to set the managed RPO. Hope you enjoyed the session today on global databases. Please give us your feedback about the session and do go ahead and try out global databases in your environment. Please reach out to us if you have any questions. Thank you for your time today.